Okay, let's get started. Good morning again, everyone. Let me start by apologizing in advance. It looks like we have some good timing. We have some problem here with the connection, so I might have to do on and off slides, depending on what the technology allows me to do, pretty much. But every once in a while, apparently, I'm going to have to shake it up and hope that it works. All right. So this is where we are at. I told you last time we are done with the building blocks. Okay. The last thing we need to do the last thing we need to talk about actually before we wrap up completely module 1 is a little bit about how we are going to combine building blocks. And I had actually an interesting question on Piazza last night. Somebody asked pretty much, I take a look at the PQ exercise and I'm not exactly sure what I'm supposed to do there. So if you are in that situation, come to office hours, right? Okay, this is what they are there for. Otherwise, this lecture is going to also help you with the last problem of the PQ, okay? The first problem of the PQ, it's pretty much, you look at the slide, you learn what a building block does, and then you see a building block, you tell me what it does, right? So if you are stuck there 99% of the time, it's because you haven't yet memorized what the building blocks are doing. So put in a little bit of elbow grease, study, you are going to get there. If you put in the effort and you are still stuck, then this is when we need to talk, okay? But there's nothing wrong with realizing, well, I didn't memorize those things and now it's coming back to bite me a little bit, so I need to change my learning strategy, okay? All right, so we talked about the 6 building blocks. That's all we need to write actually code like this kind of stuff. So this kind of stuff is the kind of stuff you are going to see on the PQ, on the GQ. The actually collaborative GQ is a little easier than that. It's not on tracing code. It's mostly about errors and stuff like that. But this is like the type of code that you should be comfortable with by now. So what do we have inside there? We have a class declaration, always necessary. Some of you have been asking me, why can't I run fragments of Java code? You can't. Well, you can, but we'll talk about that out of class if you're curious. In this course, you always have to declare a class, declare a main method, and then here goes your code. Okay, this is what you want the program to do. And if necessary, some part of this code are going to be in separate functions, methods, and you are going to call those methods when you want to trigger that code, okay? So we have here declaration of a variable. The while loop here is using a slightly different type of condition. So we know it has to be a Boolean condition. We don't have a choice. So now we look at it and we say the Boolean condition is value equal math the square root of value. So that's not the kind of Boolean expression I've been using until now. Until now, I've been using an expression where I have something, I compare it to something else. Well, here's my comparison operator. The something on the right-hand side of the comparison operator is nice, 1. That's easy to evaluate, 1 is 1. This one here is just an expression. The expression needs to be evaluated, so I need to do the work to compute what this is equal to, and then I'm going to use that value, compare it to 1, etc. So this is how programming works, right? We have very simple building blocks, but now you need to also understand the rules by which you can recombine those building blocks with one another. The good news, if you mess it up, the compiler will yell at you. Okay, this is something the compiler will always catch before you even have a chance to run your code. If you don't write proper Java, the compiler will tell you something is wrong. So try to simplify. Okay, try to get the same work done, but in 2 lines instead of 1 line, and generally that will simplify things, that will allow you to move on. Inside the loop, system.println, whatever value is here, and then system.println the value at the end. So the building blocks themselves, you have to memorize them. If you don't memorize them, you don't know them, you kind of gave up on the class already, okay? So I cannot help with that if you don't want to memorize them. But once you memorize them, it's simple. Each building block has a very well-defined function, a very well-defined meaning. It's not ambiguous. When you write code like that and you put all those building blocks together, it's the details that are going to get you. For example, if you take a look at this code here, is there anything there that looks suspicious, out of place, erroneous maybe? Insert whatever adjective you want here. See why I said that it's like playing Where's Waldo? You wrote, yeah.
Line inside of the while loop, and then there's one outside of it.
Okay, does that make sense? Every time I iterate, I'm going to tell you the value, the current value at the iteration, and then when I'm done, I'm going to display the final value. Okay, so the last value that's displayed here, when I display it, I reach the end of the loop, I go back, I test my condition is false, I get out of the loop. Guess what? I'm going to display twice the same value. So maybe that's something I don't want. You're correct. Okay, what else? It's all in the details. Yeah. I'm changing a value inside the while loop. Yeah, I can. But that's the detail I wanted to draw your attention to, okay? I'm using only the stuff that I covered so far. But the one thing that I didn't really, I think I mentioned it in passing, like really fast like that, but maybe I didn't even mention it to both of my group. So don't worry if you missed it, okay? But when we talked about assignments, assigning a value to a variable, okay? I didn't mention that an assignment is also an expression. What does that mean to be an expression? To be an expression means that when you run that code, the whole code results in a value. And now you use that value for whatever, for example, assign it to a variable or something like that. Or if this results into a value equal math the square root of value, then that value is going to be compared to 1. So I'm doing two things in that line, okay? I am first computing math dot square root of value. Actually, more than two things. So first thing, I'm computing math dot square root of value. This returns a value to me. The second thing I do, I assign it to the variable value. So the variable value changes. If you were looking at this loop without paying much attention, you would probably look at it and say, is this an infinite loop? Is this a loop that never stops? Because for a loop to stop, you have to have a condition and you have to have something in the condition that changes from one iteration to the other, right? If the condition never changes, there's no chance in hell that your variable will ever change value and therefore probably end up having this condition get to false, then your loop is going to spin around forever. So the second thing we do is we assign the square root of value to the variable value, which means the next time we spin around, we have the value that is the square root of the original value. Now we apply square root to it again, and we store it in the same variable. So we keep overriding our variable with the square root of the square root of the square root of the square root, and so it keeps getting smaller, okay? And what we say here is, in addition to computing the square root and two, assigning the value of the square root to the variable named value, the third thing that I do is an assignment is an expression. So when I'm done executing value equal math dot square root of value, that whole piece of code here is replaced by the result of the square root that I just assigned to the variable value. When you assign a value to a variable, that expression itself yields the value. So you can use it in another expression, you can pass it as a parameter, you can do whatever you would do with the value itself. So you have what we call a side effect. You change the value of a variable, and at the same time, you have a result out of this expression. And then I compare that result to 1. I'm going to keep doing the square root of the square root of the square root of the square root of whatever is inside the variable value, which at the beginning is 12, okay? And I'm going to keep doing that while the value that I get is greater than 1. As soon as I get below 1, then I'm going to exit, display the result. And as you pointed out, I'm displaying the result twice, because at every step of my computation, I still display the result so that you see what's going on, okay? So we're going to see that square root diminish, reach a number that is below 1 for the first time, and then it's going to display it again, and it's done, okay? So, like I told you at the beginning, there's really nothing to do here except me repetitively point out to you that the devil is in the details and encourage you to train yourself to look at that code, any piece of code that you work with, like really carefully, like playing Where's Waldo 24/7 pretty much while you're coding. Yes. Yes, that's correct. Yes. One of the common misconception. So what you said is correct. Okay. As soon, not as soon. You didn't say as soon. You said it well actually. You said when this is false, right? I stop the loop. When the condition is false, I stop the loop. One of the misconceptions that I see one or two times every semester, it's students that think as soon as the square root is greater than 1, the loop stops. Okay. So imagine that instead of doing just system.out println value here in the middle, imagine that I would have like 50 lines of code right here. Okay. So if at some point during the execution of those lines of code, if at some point the variable value becomes smaller than 1, do I get out of the loop immediately? Thumbs up, yes. Thumbs down, no. No? Yeah, it's no. You see that? The deal is you execute sequentially, right? Building block 0. So you execute this line, you compute all this stuff, you assign the value to the variable value, you compare what you just assigned to 1, and you decide true or false. If it's true, you execute this, then you execute the next statement, and the next statement, and the next statement. But if at some point one of those statements said, for example, value equals 0, who cares? You just change the value of the variable named value. I should pick a different name, I guess. But you just change that value to 0. It's lesser than 1. But you are in the middle of this code here. You're not testing that. So you're going to keep churning out, statements until you reach the end of the loop. Only when you reach the end of the loop, you rewind. Only when you rewind, you are going to again execute that line. And this is where you compute the square root, you assign it, and you compare it to 1. So you don't get out of the loop magically because the condition becomes false. Okay, I just want to clarify. I don't think this is where you were going, but I want everybody to be on the same page. But the next time you check the condition in the order of the statement execution, right? This is when you're going to realize that it's time to quit. And that's it. Okay? All right. So, yeah, be wary of those little details. PQ01, a lot of you have I saw on Blackboard, on Canvas, or I still call it Blackboard. I saw on Canvas that a lot of you have started practicing with the PQ1. Okay, that's good, perfect, awesome. The PQ1 generates random questions. The first one or two questions, I don't remember, they are just on the building blocks as is. It's almost like the same thing that we saw in the slide, but I changed, the name of the variable, I changed some numbers. Instead of the loop spinning 10 times, it's going to spin 12 times. That's it. Okay. So use those first questions. By that time right now, even before this lecture, you should be comfortable with those questions. If not, come and talk to me as a TA. Okay. The last question in the PQ1 is trying to throw together a little bit more complex programs, still using only the building blocks that we've seen, but trying to recombine them a little bit in a, I don't know how to call that, maybe a more realistic way. Okay. So use those after this lecture to make sure that you not only understand the individual building block, but also how to assemble them together. The practice exercise 01, I'm going to give you 4 of them. Okay, these are exercises from the textbook. You don't need even to go and fish them in the textbook. I'm going to give them the content of the exercise in the next slides. Okay, so everything will be included in the slideshow. What I want you to do with those exercises, I want you to use them to make sure you can identify all those building blocks. And this is trivial. This is meant to be trivial, but middle of the semester, I'm going to have people that tell me I don't know how to program. And when we scratch a little bit the surface and I tell them, well, what is this loop doing? They tell me, I don't know what the loop is doing. See the problem? So this stuff needs to be 100% clear in your mind, okay? The stuff at the end of the semester, if you're like 90% okay, you're good. You still know how to program. But this stuff, if you don't know it 100%, you're not even getting started learning to program. So I'm going to give you 4 pieces of code. And I'm going to ask you to identify, so you can use a marker, you can use whatever you want, you can just do it in your head, it doesn't matter. But I want you to decompose that code into building blocks. Identify all the building blocks, okay? What is a building block 0, where it is, where it starts, where it ends. What is a building block 1, 2, 3, 4, 5, and so on and so forth, okay? Here's an example of code here. I don't remember what it does. Apparently, at some point, we read 3 numbers. So as we go through those code examples, I'm not going to detail them. These are your exercise. but I'm going to point out a few things that are new. So the println, we talked about it. Okay, there are two versions of print and println, depending on whether you want to go to the next line. The scanner, we only use one method from the scanner, next int. So we would declare a scanner, here the scanner is named input. So that means I could use something like input.nextInt. But what if I want to read from the user a floating point number, a double data type, okay? NextInt is not going to cut it. So the method that you call to read data from the user or read data from a file, you have to choose the method depending on what kind of data you want to read. So right now we're dealing only with numerical data. So the choice for us is, am I dealing with integers, round number, or am I dealing with floating point number with a decimal dot and some decimal places, okay? If you are dealing with int, next int. If you're dealing with double, next double. Just don't forget to capitalize I or the D, okay? This is camel case notation. But other than that, you're fine. So here's one more method from the SDK to add to your list if you're keeping track. The next exercise is going to introduce a little notation again that's new. So I'm just using that as an opportunity to introduce little details. These things are not critically important, but they just keep adding to your vocabulary, to your toolkit, okay? We do something weird here. We declare a scanner input. We declare a radius variable. We declare an area variable. So all of those three guys, yeah, exactly as we did them before. But then we declare a variable, double pi. First thing I notice, the name of the variable is weird. Normally, variables start with a lowercase and they do camel case. This one is in all caps. And if I had multiple words in it, we would use the underscore symbol to separate them. Why a different convention? Because this variable is meant to not be modified. It's a constant. So how do you say in Java, I want a constant named pi, all uppercase, equal to 314.15.9, and I don't want, whatever happened, I don't want any part of the code, even by mistake, to modify that value, because that value needs to remain the same. It's a constant, it's a mathematical constant. You just add the keyword final in front of it. So one more Java keyword. I don't know if somebody kept track, I didn't, but we probably are around like 15 now, something like that. So final, then the data type, double, then the name of the variable, all uppercase by convention. Java doesn't care, but we care as programmers. And then the value you want. And then you get a constant. So the constant, what it does is, let me show you, because some of you are going to bump into that at some point when you use JGraph. So this is a code from last time, actually, last afternoon session. So let me clean that up a little and just use the main. I'm not going to use the extra method for this time. Actually, I'm going to even remove it. There's no point in compiling stuff we don't use. There we go. And I'm going to do int value equal 42. Okay. Value equal 99. I changed my mind. That's what we have been doing with variables. By the way, if I'm typing like that and at some point the screen goes blank like it did sooner, just let me know. Okay, yell or say something or wave, I don't know. So if I use that, thank you. So I guess I have to move the mouse constantly or something like that. There's a thing, it's an exercise thing, I don't know. All right, if I run that, it displays nothing because I didn't display anything, but if I run that, it declares initialize to 42, then assign 99. The compiler is okay, the program runs, okay? If I say final int value and I try to compile it, that's the only thing the final keyword does, really. It's going to allow me to say, I don't want to be able to modify value anywhere in my code. So again, it's a difference between languages that are, languages that work with the programmer, assuming the programmer knows everything and should not be like hindered. And there are languages that actually require the programmer to have some discipline. Java requires us to have discipline, okay? It doesn't allow us to have discipline. It requires us to have the discipline. It makes sure that we have it. So if I want to make sure that the thing does not modify, I slap it with a keyword final. And now the compiler will check for me that I'm using that variable properly. It's a variable that cannot change once it has been assigned a value. And if I have something like this, guess what's going to happen here? I just Control B, compiled. It's compiling. Why is it compiling? I declare my variable as a final variable, a constant, and then I try to change its value. Why is Java letting me get away with that? Any idea? Say that again? Yeah. I didn't have anything here, right? So that means if the variable is not initialized, Java will say, oh, you want a constant, but you didn't give it a value. I'm going to wait. And somewhere else in your code, at some point, you are going to assign a value. The first time you assign a value, that's it. The value is locked in. So if I try to do something like, for example, value equals back to 42 here, then I try to compile this, and now it's yelling at me. So the final keyword, yes, is like a constant. It means pretty much that variable can only be assigned a value one time. Yeah. Why did I uppercase value? Why didn't you? Did you say it has to be capitalized? You're correct. You're absolutely correct. I did not uppercase value. Yeah. Oops. Okay, so the primary rule in this course is do what I say, don't do what I do. I'm just kidding. But you're absolutely right. Constant, it should be uppercase, as you're going to be able to see probably in a second. There we go. So, and that's, you see, the compiler doesn't care about it. It's really just a courtesy to other programmers so that it's really easy for me to spot, in your code or you in my code, okay, this variable, I should not change it. It's spelled all uppercase, right? And other programming languages do that kind of stuff even more, actually. Python, for example, there are things in Python that the compiler is not even going to check. Like if you want to have, I'm going to talk a little technical here, but if you want to have an attribute in a class in Python, and you don't want that attribute to be usable by every other part of your code, you want to kind of like, lock it to your own usage, to the usage of only the code for that class. Well, in Python, you just name it with an underscore at the beginning of the name. And it's a convention. Every Python programmer knows that if I bump into a variable, that has an underscore in front of it, I should not touch it. I should not change it. But Python is not going to stop you from changing it. Java will tell you, you have to tell me what specific variable must not be touched, and I will enforce that for you. I will make sure that nobody modifies them. You see the difference when I say flexibility between Python and Java? Same thing with the final keyword, right? We don't need a final keyword. We could just all agree that if I spell my variable all uppercase, then nobody change its value. So some people think that having to add final is bothersome, okay? It's just a compiler check, okay? So you don't have to worry about getting it wrong. All right, so I'm going to switch back, and I guess this is where the screen goes blank for a second every time I do this. No, maybe not. I'm going to understand what's going on here one day, I promise you. But what I would like is for you to be able to see the slide now. Yeah, there we go. So we have two more exercises like that. This one doesn't have anything new. Okay, so just identifies the building block, and that's it. I think I skipped over one of them, but it didn't have anything new either. Last thing, recombining the building blocks. So what are we going to talk about here? We've seen already examples of this. Give me an example of a statement, please, that has two building blocks, one inside of one another. Yeah, that would count. We haven't seen that yet. I was careful to avoid it, but yeah, that would definitely count, okay? What are the ones that we have seen already? Remember that while value equal math.sqrt. So what's going on? It's a while building block, right? But inside the condition of the while, I have what? I have the not the declaration, the assignment of a value to a variable, right? Value equals something. So that's already one building block inside the other. And then what is the value I assign? Math.square root. It's calling a method. So it's really like, snapping blocks inside of blocks like that. As long as you know the rules to snap them correctly one inside the other, then you know how to write code. And then if you snap a block that doesn't fit, the compiler will tell you, don't worry, okay? All right, so we've seen examples already. What I want to do is I want to go a little further and get to what you were describing, which is, what if I start putting a loop inside of a loop or something like that? Before we do that, so this example here is a piece of code that has, let me start by looking at the code and then we'll talk about the modulo operator. This example here has a piece of code that has a counter control loop. To make it obvious, I even call my variable counter here, So in counter equal 1, counter lesser than 5, I'm looking for where is the counter increased here. Counter equal counter plus 1. It could be increased, decreased by 1, by more, whatever, doesn't matter. But these are my 3 pieces for the while building block, right? The counter control loop, more specifically while building block. The counter initialization, testing the counter every time, and then at the end, before the end of the loop, moving the counter, incrementing or decrementing, so that eventually this condition becomes false. And then inside of here, this is a composite building block, call a method, and then an if statement. So we know how this works. So if I put them one inside the other, you should know already how this works. It's just going to take you a little bit of a stretch, maybe for some of you, but trust me, this is not out of reach, okay? You just base yourself on what you know each of the individual block is doing. And then just because we need to add a little bit of things as we move on, so I added the keyword final, that is kind of like a side remark, etc. Here, I'm adding in this example, a new operator. It's an arithmetic operator, just like star is a multiplication, slash is a division, plus, minus, stuff like that, right? It's a percent sign. The percent sign in Java, I don't remember. I think Python and JavaScript are the same way also. Most modern language use the percent sign as a modulo operator. So what does it mean, modulo operator? If I tell you what is 5 divided by 2, what's the result? 2.5, right? So you automatically go to, I'm going to give you the true result, right? The decimal result. But I told you that in programming, this is more than the value, okay? Each value has a data type, and depending on the data type that you play with, the mathematical operation can be slightly different. For example, if I did 2.0 divided by 5.0, I would get 2.5. A floating point number divided by a floating point number yields a floating point result. If I do 2 divided by 5, integer divided by an integer, I'm going to get an int. So what would that be? 2 divided by 5, 5 divided by 2, sorry, that's going to be 2. I don't care about the decimals, okay? So sometimes you want to perform what we call sometimes an integer division, okay? You want to perform the division of 2 integer value, and you want to just stop, not go into the decimal place. But you want to, at some point, access the value of the remainder. That's what the modulo operator allows you to do. When you write something like 11 modulo 2, okay? 11, actually, this is division like regular division. 11 divided by 2 gives you 5 as a result and 1 as a remainder, right? So if you divide with a slash to int, you get the result. If you use the percent operator, if you use the modulo operator, what you get is instead the remainder. So 11 slash 2 equals 5. 11% 2 equals 1. So the remainder is a very convenient way to check things like, for example, is a number a multiple of another number? If I do, for example, 10 modulo 2, right? I divide 10 by 2, this is 5, remainder is 0. Well, that means that, 2 goes into 10 exactly 5 times. So it's divisible by 2. It's a multiple of 2, right? Okay, if I get a remainder of 0, I know it's a multiple. If I get anything else, well, no, it's not exactly a multiple, okay? So I can use that with modulo 2, and you are going to see the textbook use that a lot. I use that with modulo 2 to check if a number is even or odd. What happens when I have an even number? Let's say counter is equal to 10. 10 modulo 2. I divide 10 by 2. What is the remainder? 0. Okay? So that would be true if the value inside of counter is even. If it's odd, like 11 modulo 2, 11 divided by 2 is 5, integer division, right? The remainder of that integer division is 1. That's it. It's an odd number. Okay. So that's just a little side trick, but it's used so much in like beginning exercise for people that are just learning to program. You're going to see that used in coding bat and stuff like that. We have to introduce it early on at some point. What about now? It's as good as any other time. So that's kind of like a side remark, but back to the original flow of thinking here. We have a piece of code that's getting more complicated, but we still can track it. So again, based on what I've seen in previous years, previous semesters, etc., I know that some of you are going to look at this code and say, and kind of give up and say, I don't know how to read this amount of code. The code examples that I've seen so far in the lecture were not that complicated. For example, the code example that we have seen so far never have a loop inside of a loop. Well, that's the next bullet you need to bite. Okay, as you are learning to program, you need to not only learn to replicate what you have seen, but you learn to replicate the usage of basic elements and recombine them differently to solve different problems. That's all there is to it. So it's at the same time easy, but if you have the mindset of, this is a course where I need to memorize a lot of stuff and then, spit them back. If you have that mindset, then what's going to happen to you is that the first exam we have together, you're going to come back and tell me, that question, that program you asked me to write, I've never seen it before. Correct. Every program I'm going to ask you to write, you should have never seen it before. There are some programs in Coding Bat or whatever that Google has seen before, okay? But when I do exams, generally, I do stuff that you cannot find on Google either, right? So the idea is that's the nature of programming. The nature of programming is not repeating recipes that you learn by heart. The nature of programming is reusing the basic elements that you learn to use and you really understand what each of them do and recombining them in a novel way to solve every day a new problem. Okay, so when you have a piece of code like that, again, I know this is not everybody, okay, but I'm going based on what I've seen, like for years, students do, some students do, okay? I've seen students pretty much look at this, and when I ask them what is going on in this code, they start reading the code, and then if I ask them, okay, so you understand what's going on? They said, no, I don't know what to do with this code. I don't know how to modify it. So I ask again, what is going on with this code? And they read it again. That's not how you're going to understand code, okay? Code is structured. That's why we went through that, here's a building block and here's another building block and all of that stuff is so easy, right? But when you look at a piece of code like that, I want you to see it differently now. I want you to look at a piece of code and say, the first thing is a statement, a single statement, standalone statement, building block 1, declare and initialize a variable. You know what building block 1 is. It's not difficult. You can just memorize it, right? So you understand the first line of code. Okay, let's move on. What happens next? What happens next is not while counter lesser than 5 system.out print counter. No. What happens next is that I have a statement here that is a composite statement. This is a while loop. So I know there's going to be a repetition. And in my mind, I have already put like a blue box around that code. And I know this is the only part of the code that's going to be repeated. Okay, so every semester, some students are going to say, well, I don't know if this gets executed every time I loop or, just after the loop or what. Don't panic. If you don't know, that means you don't remember what the building block is, right? So go back to the definition. The building block starts here, ends here. That's your loop. Visualize it like that. And then you start thinking about, okay, what's happening at every iteration of the loop? I haven't yet looked at the condition. I don't know how that loop is working. I don't know what's going to make it stop one day. But at least the structure is super clear. The structure is declare a counter here, then start a loop. I see that it uses a counter. I see here that it increments by 1. This is a counter control loop if I want to be that specific. And then inside the loop, what am I going to repeat? Calling a method, and then another composite building block. So sorry. Calling a method, and then assigning a new value to the counter, and then my composite building block here, which is an if statement. So I'm going to choose to execute one of two possibility of code here, this code or that code at every iteration. So every iteration, one of the two pieces of code is going to trigger. And then those pieces of code are just calling methods. If you look at a piece of code like that. And for some of you, maybe most of you, I don't know, this is already coming natural. Perfect, awesome. I just want everybody to be on the same page, right? When you look at a piece of code, if you have never looked at a piece of code before, don't read it top to bottom. It's not a novel. It's not a story, okay? Yes, you read it top to bottom, kinda, but you really internalize it in your brain like this. I'm not looking at int, while, etc. I'm looking at, this is a counter control loop that's going to decide at every iteration to display even or odd based on whether counter is even or odd. That's how you need to read code. And it's going to take a little bit of practice if you've never done before, like everything, right? But you are going to get there, but you need to have an objective. You need to know exactly what you're shooting for, okay? It's not good enough for me to show you pieces of code and tell you, well, you've seen 50 examples of code, now you guys know how to code, right? No, I want to explicitly point out to you what you need to learn, what you need to study, what you need to acquire in terms of skills. And if you have problem, the door is always open, office hours, you know the drill, right? All right, so now that we are talking about recombining building blocks with one another, how many possible ways are there to recombine building blocks? Not that many. Again, it's a chessboard analogy, right? We have a few pieces, we have 6 building blocks, and for each time you want to put a building block inside another block, you have to decide pretty much if you want to arrange composite statement in a serial manner or in a nested manner. Serial mean, just like in physics when you learn circuits and stuff like that, serial mean one after the other. I have a loop, I have another loop. I have an if statement, I have a loop. I have an if statement, another if statement, and I have another loop. All of this is one of those composite statements at a time. And then I have a loop inside of which, previous example I had on the slide, inside of which I have an if statement. Inside the first part of the if statement, I have another loop. Inside that loop, I have another loop. Inside that loop, I have another if statement. How far does the rabbit hole go? There's no limit. There's no limit. So in practice, when you work for a company, if you write a method that has a loop inside a loop inside a loop with an if statement, and inside the two parts of the if statement, there is a loop in each, and inside those loops, there is another loop, and the people are going to look at you like you're crazy. They're going to tell you, do you really want to make your life miserable in this company? Or do you want your car keyed in the parking lot? I don't know which one is going to come first, right? The bottom line is that, yes, nobody likes to deal with this kind of code where you have like nested levels, nested level, nested level. The rule of thumb that people say is, okay, if you go above 3 levels of nesting, maybe you should redesign your code and use more methods. Okay, put some part of your code in a separate method, call that method so that it doesn't look like so complicated to read. Yes, we care about making things easy to read. Some of the exercise that I'm going to ask you to do in coding that, they are going to force you to nest at up to 4 levels. That's your rite of passage, okay? Take it like that. You do that one time for me because I just want to make sure that you are pretty much working out your brain so that you can handle nesting, construct, etc. Keep track of things. It's like a workout, okay? We push you a little bit to the limit. And then when you write code, by all means, I'm going to teach you to write code that doesn't get your car keyed in the parking lot. So I'm going to teach you to not nest, at infinity. But potentially, you can nest as much as you want. Now, here's the question. If I give you one of those pieces of code, let's say at our IE exam, IE2, I'm going to, actually, before I talk, I should remember what I put in IE2, so I'm going to shut up. But one of the upcoming exam, I'm going to give you a piece of code, for example, and I'm going to tell you, what does it do? What is the output of this code? And the code is going to be a page long. So how do we go from those building blocks that are trivial to detangling a code that is a page long? Remember that diagram here on the right? The block inside block inside block? Yeah. If you read the code as a block of text, there's no way in hell. Very few of you could read the code that is one page with a bunch of stuff nested, on purpose to make it complicated and tell me what it's going to do and be right. Very few people. The rest of us, mortals, we are going to look at the code, break it down in our head into blocks, and figure out progressively what it's doing. Look at it a little piece at a time. So it's a leitmotif in programming. Remember when I told you we could not manage a million lines of code in the main method. We have to create separate methods, right? We create little boxes that we really understand what it's supposed to do. It does it in like 20 lines with 2 levels of nesting. And when I look at it, in 10 minutes, I can figure out exactly what that other programmer did. That's still what we're talking about here, okay? We're talking about abstraction. We're talking about being able to visualize things that are huge and complex, to visualize them in terms of their internal component, so we can focus on the component that matter when we are, for example, looking for a bug. So very, very, very important, that decomposition, okay? So we're going to take examples of pieces of code. I'm going to start preparing you to, pretty much what we are going to do in the next module, which is tracing arbitrarily complex code. So right now, the tracing that we did, tracing just means, look at code and tell me what it does. So the tracing that we've done right now was like freestyle tracing. I have a loop. I learn what a loop is. I have an example of a loop. It looks exactly the same. What does it do? Okay, trivial. Well, now I change a few values here, a few variable name, etc. What does it do? Okay, still simple. Now I'm starting to put a bunch of loops inside one another, etc. What does it do? To trace arbitrarily complex code, we are going to have a method, and I'm going to teach you that in the next module, okay? But for now, the most complex we are going to get is, instead of telling you what does this loop do, I'm going to ask you what happens in this code when I have this loop, which is a basic loop like we've seen in the building blocks, followed by another basic loop. Or maybe this loop with another basic loop inside. That's the only 2 things we are going to do. One after the other, one of the building blocks we studied after the other, or one inside the other. Stop. And that's as far as we can go, or at least that we are going to go in terms of looking at code and trying to tell me what it does. When the code is going to start getting bigger, more complex, more nested, then we'll have to actually, all of us, will have to pause and use some sort of method, use a piece of paper to keep track of things, use some sort of notation to be able to trace mentally through the code in a reliable manner, okay? So take a look at this code here. So what do you see? You see 2 loops, right? So what is this code going to display? When you have a good idea, or you think you have a good idea of what the code is going to display, just give me a thumbs up, okay? So that I know when we have like 2 or 3 people that are already there. And if you are still looking, take your time, take a minute, look at this code, break it down into components, and then you know what the basic components do, each of them. So what's going to be the final behavior of that code? Okay, 1 thumbs up, 2, awesome. Okay, another thumbs up. Awesome. Another 1, 5, 6. Okay, so we're going to do 2 things, okay? First, anybody who raised their thumb, one of you, can you tell me what you think this code is going to do? It's going to print 6 zeros. Okay. What else? Another option? Somebody came up with a different solution, yeah? Okay. All right. Another option? So these are the 2 solutions that you guys came toward, converged toward, okay? So first thing to notice, right? We all look at this code, and it's not unusual for different programmers to look at it and say, I understand different things here. That's why next module, we are not going to just look at the code and say, this is what it does. We're going to use a more structured approach to pretty much figure out what any piece of code is doing, okay? But right now, we are trying to just map blocks, so here's a loop. Is it a counter control loop? Well, yeah, it looks like 1 because look, I use a variable n1. I check if n1 is lesser than or equal to 5. So 5 is kind of my limit for n1, right? N1 starts at 1. N1 here is checked as long as it's lesser than 5, I keep iterating. And at the end of each iteration, I increment 1. I increment n1. So it starts at 1, then it goes to 2, then to 3, 4, 5 eventually. And when it reaches 5, it's still okay. But when it reaches 6, next iteration, I'm going to break out of the loop. Okay, so I don't know the details, but that's what I'm looking for here. So I have a loop here. I have another loop here. What kind of loop is it? It's also a counter control loop because look, it uses a variable n2. N2 is set to 5 at the beginning here. And then I keep checking, is n2 greater or equal to 1? And then let me check what happens at the end of my loop. N2 equal n2 minus 1. I decrement n2 by 1 every iteration. So I'm going to start at 5. Then I'm going to do 4, 3, 2, 1. When I'm at 1, this is still true. I execute this for one last time. When I reach 0, I get out. That's, and I'm not like sure of myself yet. Okay, at this point, I should not be sure of myself. I'm not yet ready to tell you, it's going to start displaying 1, 2, 3, 4, 5, then maybe 6, 5, 4, 3. No. I don't know exactly where it starts, where it ends, but I get a basic sense of what's going to happen. We are going to count up from roughly 1 to 5. We are going to count down from roughly 5 down to 1. What do we do inside? So here I display loop 1 as a header, right? This is what loop 1 is doing. Then this is what loop 2 is doing. So that's okay. Inside the loop, every time displays a value of the variable n1 here, the value of the variable n2, followed by a space, and keep doing that. So those loops are going to display numbers one after the other on the same line. When I'm done with the first loop, I will go to the next line. So I'm going to display loop number 1 with that arrow. Then I'm going to display after the arrow all the numbers that I count. Then I'm going to go to the next line. Then display loop number 2 with an arrow. Display on the same line all the numbers that the variable n2 takes. And then system.out.println. Does that make sense? So I know this is not the kind of question people like to answer by raising their hand, but I need to take the temperature once in a while. So let me try to phrase it positively. How many of you are 100% confident if I give you this code at an IE, I ask you what does it do, you're going to get it right? Cool. Awesome. So if you are not confident, guess what? Office hours, right? No, but seriously, this is your warning, this is your sign. That means like, well, okay, there's something there. I understand the gist of it, I understand how it goes, but there are too many details that are like shadowy, blurry for me to be able to apply this reliably. If you're in this situation, that's perfectly normal. You're just learning this stuff, right? So, but seek help now. Come and talk to us, okay? So, all right. So we have pretty much done the dirty job version of tracing the code. And in that case, yep, we got it right because we were lucky, because the code was simple enough, yeah?
Or one less, but only print out up to 5? Because it looks like it's going to add 1 to 5 at the end, but it only prints up to 5. So
yes.
6, right?
Yes. So when we trace in detail, right on. When we trace in detail, like for example, n1 is 1, right? 1 lesser than 5, true. So go ahead, display 1. Then increment n1. n1 is 2. Condition is okay, display 2. n1 is 3. Condition is okay, display 3. n1 is 4. Condition is okay, display 4. n1 is 5. Condition is okay, 5 lesser or equal to 5 is true, display 5. And then n1 is 6. And when I go back here, false. So yes, and this is where what I told you when I said, you know what, I kind of see what's going on here, but I'm not yet comfortable telling you, it starts at 1 and ends at 5 like you did, and then it goes from 5 to what? Because the problem with loops and counter control loops is that it's so damn easy to be off by 1. And I don't care how many years you have been programming. Even very good programmers, they still do that mistake once in a while. We each have a brain fart at some point. The idea is, yes, sometimes we are off by one because we get focused on, I'm counting from 1 to 5. So if I ask you here, what is the value of N1? 5. I was just thinking, this loop does 1, 2, 3, 4, 5. So I cannot give you a gut answer. The value of N1 is 5. And we do that all the time. So you have to be careful. You have to be mindful about not jumping to conclusion, especially when you read code, because all the problems are in the details. Okay. So like you pointed out here, when I end this loop, if I were displaying the value of N1, it would be 6. Does that make sense? Yes. If you understand how the code works, it makes sense. If you look at this and you think, yeah, this is a counter control loop, it counts from 1 to 5, so at the end the value is 5. You sound like you're making a reasonable argument, right? But that doesn't matter. And most of the time when we program and we have bugs, we write code. We write code because we think this is correct code. We never write code, thinking this is a lot of crap, this is never going to compile. I'm so proud of myself. No, we write code thinking, oh, I know how to solve this problem. If I write this, this, and this is going to work. So we always have a bias toward our own code. My code is good until the compiler yells at me, until I run the code and it doesn't do what I expect. Then the first thing you have to give up is that assertion. My code is good, okay? And it sounds trivial, but I've seen countless people try to just rerun their code. I even do that from time to time, and it's stubborn. I cannot believe my code is not working, right? And then I rerun it. No, that's not the solution. The computer is very seldom wrong. It happens, but it's very rare. All right, so count to 5, count down from 5. What if we change this code? Just to show you like details matter, right? I'm going to change this code, and here's the new version. And the new version says, you know what? I don't need two variables, N1 and N2, because N1 goes from 1 to 5, right? Actually 6. And then N2 goes from 5 to 1. So what if I was reusing the same variable? So I'm going to say, okay, I'm going to just use N equal 1 here, one variable instead of 2. So this guy is going to become very similar, N lesser than 5, display N plus 1, nothing changed, except the name of the variable. And this guy here, nothing changed instead except the name of the variable. If I run this, what's going to be displayed this time? Yeah, go for it. Sorry, you are 20 years too late. My hearing is not that good anymore. Yeah, exactly. Okay. So the ID, okay, based on that remark about the 6 is there somewhere floating in middle. Yeah, now it matters. Here, I could look at this, predict what it does, feel good about myself, and as a matter of fact, I didn't really know what was happening. I just had, lucky guess, one of those 2 wrongs make a right. I don't know what this is exactly, but I was able to tell you what it does, but maybe I didn't I didn't think that N1 would be 6 here. In this version of the code, that becomes important. So if I run this version of the code, and I encourage you, by the way, to cut and paste those things in JGrass, play with them. The whole thing is, this is not supposed to be natural. Nobody is born knowing to program. I mean, we are getting there progressively. You guys are learning to program earlier and earlier. Your kids are going to learn to do that in a primary school, right? But the bottom line is that at this point in time, our species is not born knowing how to program. So how do you get good at programming? You get used to it. So take those pieces of code, cut and paste them, run them, observe what they do, get familiar with how they tick. Here, because of the reason we discussed sooner, N1 was 6 here, so N is 6 here. Then what I do is 6 greater than 1, true, display 6. And then N equals 6 minus 1, 5, and then I display 5, and then I display 4, 3, 2, 1. Yeah. It goes from the first loop to the second loop. It just follows the execution, right? Building block 0. I have a huge block of code. It does every statement one after the other. So when it executes, imagine like this is an execution, right? It executes this, rewind, this, rewind, this 5 times, and then here, and guess what? The variable is still there, right? So I use the same variable n, and then I get here, and then I get here. I use the value of n, and then I get here, spin a few times, and then finally I get here. So yes, everything here is inside my main method. It's inside that one block, and the value of n is not reset automatically. That's the other thing that throws us off when we code. When we code, sometimes we think, we are thinking in high level terms. We are thinking, I'm done with my first loop. This variable should be reset. If it's not written in the code, it's not done. Yeah.
So why didn't it show 6 with that first code?
So it did an initial 6 here because when you reach, let's play back the movie here. When n is 5, okay? So I've been spinning already a few times. I'm here. N is 5. This is true. Display n. Display 5. Display a space. There's a space. N equal n plus 1. N is 6. Rewind. Is n less or equal to 5? False. Get out of the loop. Display a println, so that gets me here, ready to print on the next line. Print loop 2 a row. N is greater than 1. Yes, 6 is greater than 1. And then so on and so forth. So 6 get displayed here, and then so on and so forth, right? So the only difficulty here is what? Keep track of n. So I can do that. I can do that in my head. And then until I mess up. And then I mess up and I realize, I should be more careful. I'm sloppy. I was doing this, but at the same time, I was thinking about I got bills to pay when I come home and stuff like that. So I got distracted, and this is how I messed up. So I'm going to say, okay, I'm going to do better than this. The value of n is here. It's my hand. So I'm going to say, okay, n is 1, 2, 3, 4, 5. As I read the code, I keep track of the value of the variable, right? Up to 6. What do I do if I have 2 variables? Well, I hope they don't go above 5 and I use both hands. And then you get the point. I'm going to be on my back, trying to use my hand and my toes or whatever. There's limits to how much I'm going to track, okay? In cognitive psychology, they have this saying, I don't know what it's based on, that we can memorize about 7 to 9 numbers, 7 to 9 arbitrary number, like very easily. But above that, it gets hard. So what if I have like 12 variables? Yeah, I'm not going to read code like that with 12 variables, and be just doing like this number and get it right. Most likely I will get it wrong. Most likely, almost any programmer will get it wrong, except if you are 100% focused and, well, you have been doing that for a while, then yeah, you should be okay. But even if you're a good programmer, you need to be focused. If you start thinking about, did I leave the stove on? You're screwed. You missed a bit, you skipped a bit. Your whole theory in your mind about what the code does is going to be completely wrong. So that's why we're going to learn to trace correctly in the next module, okay? How do we fix that problem? What if I wanted to have the first loop count 1, 2, 3, 4, 5, and then the second loop start 5, 4, 3, 2, 1? Anybody has a quick fix? Yeah? Yeah? So where would you put it? In the middle here? Yeah? Oh, okay. So you're thinking about something different. Okay, cool. All right. So if I understood your ID correctly, I was thinking about something different. But see, there are even on a simple program like that, different people can come up with different solution. Okay. The ID is if I display n and then after I increment it. Correct me if I misrepresent your ID. Okay. But if I display n and then increment it, or display n and then decrement it, it's not the same than if I do the decrementation first or next. So good point. I could play with that. Okay. Another thing that I could play with is when I am here, I know that n is going to be equal to 6. What if I add a line here? That's what I thought you were saying originally. What if I add a line that reads like this one, n equal n minus 1? Well, it's going to go from 6 to 5, and then I start with the right number, 5, right? So even a small program like that already at least 2 ways, to fix it. And maybe if we bang our head on the wall a little bit, try to be original, maybe we'll come up with a third even. I don't know. But the bottom line is that that's programming. Even with very simple programming assignment, sometimes you would be surprised how different the solution from one student to another are. Yeah?
Putting a plus or minus, just n equals 5.
N equals 5. There we go. Another possibility, right? That would work just fine. So Yes, there are multiple solutions. So when you read a solution in the textbook to a problem, when you read a solution in one of my slides or something like that, right? If you were thinking about a different way to solve the problem, you know what? Don't give up. Your way might be working. So try it out. All that matters is the result. As we progress through programming classes, we are going to start to get on your case, a little bit more seriously about, you should not write code like this. This is bad code. This is bad style programming. This is not optimal. This is slow programming, blah, blah, blah. As you progress, we are going to start, also teaching you to write fast code, good code. But at the beginning, the one thing that I really care about in this class is you being able to write code from scratch yourself and have the code behave exactly the way you need it to behave. If you can master that by the end of the semester, you're good. And then we can talk about, okay, let's do it faster, let's do it. It's going to come, okay? The COP2513 will start with that, and then 3515, and so on and so forth. Here's another piece of code, 2 loops inside of one another. You could probably simplify and tell me what this code does in one sentence, because it does something that is kind of a classic exercise. So take a look at it, think about the structure, and let me know what are your guesses. Multiplication table, okay? For every row in the class, I'm going to consider every row of desk in the class. For every seat in every row of the desk, I'm going to hand out a copy of the exam. There we go. What am I doing? I'm iterating, I'm repeating the same action, hand out a copy of the exam. I'm repeating it one row after the other. And for each row, when I reach the end of the row, I'm going back and I start again, beginning of the second row. Then I go back, I start again, beginning of the third row, right? That's the structure of nested iteration. For every value of the variable 1. So that's a loop. Starts here, ends here. Inside the loop, I have another loop. So immediately I'm starting thinking about this is a situation where, I have a classroom, I distribute stuff like that, or I have a matrix maybe. And I fill numbers in the matrix, row after row, every column, I do something. And yeah, we are going to get to the multiplication table, right? But that's kind of the idea of when you nest 2 loops, you are going to repeat one loop as many times as the first loop. So if the first loop spins 5 times, and inside of it you have a loop that spins 3 times, total number of execution of the code in the middle, 15. Okay, that's it. That's the intuition I want you to have. So more specific, the details. This a counter control loop. I always try to focus on those because those are the easiest one to get a hold of how they work, at the beginning. So there's a variable 1, it's lesser than 9. So maybe 1 could be a counter. It's initialized here to a value. We keep on the lookout, making sure it doesn't reach anything above 9. And we keep incrementing it toward 9 at the end. Yes, it's a counter control loop. So now I look at it and I abstract it. I say this is a counter control loop that's going to count with the variable 1 from 1 to 9. And now I put that out of my head. I know what this is all about. This is about repeating this thing 9 times with the value of the variable 1 being 1, 2, 3, 4, 5, 6, 7, 8, 9. So what am I repeating 9 times? Well, a variable 2 is assigned to 1. So it starts at 1, it's assigned to 1. Well, this is a little wonky. Why do I need to do that? So it's assigned to 1, and then, oh, look at this. This is another counter control loop. The variable 2 is assigned to a value. I keep looking at whether it gets bigger than 9. And at the end of the inner loop iteration, I increment it by 1. So I count from 1 to 9 with the variable 1. And every time I start counting a new number for 1, I reset the variable 2 to 1, and I start counting up to 9. So variable 1 here is 1. Variable 2, 1, 2, 3, 4, 5, finger overflow, okay? Then 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 1, 2, 3, 4, 5, 6, 7, 9. Yes, I'm doing the same process, that we talked about here. What do I display? I display the value of 1. 1 x 2 equals 1 multiplied by 2. Yes, bingo. I'm displaying a multiplication table. Yeah? So that is up to you. Okay? We are kind of flexible. But what matters is that when you look at this code, what I want you to see is there's a loop inside a loop. If you look at this code and you say, this is a lot of text, okay, what does it do? Int one, int two, while, blah, blah, blah. Line per line is not going to get you there, okay? But seeing that there are two loops is what gets you there. And then you choose, do I want to understand this first or understand that first? I started with the outer loop, but if I understand this first, I'm going to say, you know what? The inner loop, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9 with a variable 2. This is a counter variable for that loop. Okay, so it repeats something 9 times. What does it repeat? It displays 1, I don't know what that is yet, but it's going to display a value times 1, then 2, then 3, then 4, then 5 equals 1 times 2. Oh yeah, wait a minute. So every time we multiply whatever 1 is by 1, then 2, then 3, then 4, then 5. Okay, is this a multiplication table? Let me check. That outer loop. Now I have an hypothesis. Is it a counter control loop that goes also from 1 to 9? There is a theory in perception that is that most of our perception are based on hypothesis checking, meaning that when I look at the class or when I see something moving in the corner of my eyes, I'm going to think there's a fly, and then I look and I check if it's a fly moving in the corner of my eye. Okay, I don't know how true that is. I'm not a cognitive psychologist, but the bottom line is there's a little bit of truth at least here that we can recognize. Okay, you don't read code completely passively. You don't read code by saying, okay, so what's happening? What are you throwing at me? An int x, okay, an int y, okay, I don't know. Sure, what else? A while? No, you look code and you go back and forth between making hypotheses about what you think is going on and validating those hypotheses by identifying the building blocks and seeing how they fit together, right? It's very structured. Yeah? All right, cool. So we talked about, you can serially arrange things, you can put them inside one another. So we took a look at two loops that were one after the other, two loops that were one inside the other. What about the if statement? That's our over composite building block, right? So here's a piece of code that uses a scanner. So int value equals 0. Scanner S is going to be my scanner. Tell the user, please enter a value. Read an int from the user, store it in the variable value. So this is going to be an int. This is a variable of type int. It matches, I'm good. If value modulo 2 equals 0, if value is even. That's a trick that we talked about at the beginning of the class, right? If value modulo 2 equals 0, that means the value inside variable named value is even. So I display, it's a multiple of 2. Else, it's not a multiple of 2. That's the end of my first if statement. My second if statement picks up where we left. They are serially arranged, one after the other, and it asks another question. So serially arranged if statement is me asking one question to you, then asking a potentially totally unrelated question, then a third question, and a fourth question, and the question don't even have to do anything with one another. Like here, I test if the value that you gave me is a multiple of 2, and I tell you on the screen if it is or not. Here, I test if it's a multiple of 3. It can be a multiple of 2 and a multiple of 3 at the same time. Or maybe it's not a multiple of 2, it's not a multiple of 3. Right? It can be both, it can be neither, it can be one of the two, right? So I don't know, but I'm asking two separate questions, and each time I make a decision based only on that condition. So when I run this code, if, for example, the user enters the value 12, what happens? So they enter the value 12 here, it gets assigned to value. 12 modulo 2, 12 divided by 2, that's 6, remainder 0. So modulo 2 is equal to 0. Println, this is a multiple of 2. You know how this statement works. It's one or the other. So I executed this because this condition was true. Then I skip the else. And now I ask another question. Is 12 modulo 3 equals 0? Well, 12 divided by 3, etc. equals 4. Remainder equals 0. So it's going to display this is a multiple of 2. And then this is going to display this is a multiple of 3 because this condition is true and skip the else. Two independent questions are being asked, okay? and just do it like as you review the slide, or cut and paste this and run it a few times to get confident that you know what it's doing exactly. But if I start entering values like 9, for example, well, 9 is not a multiple of 2, but it's a multiple of 3. And then 4 is a multiple of 2, but not a multiple of 3. And then the last example, 7, is actually not a multiple of 2, and it's not a multiple of 3. So that brings me to an interesting concept that we're not going to touch for maybe 2 more weeks, okay? But I want to start seeding it in your mind. Here's a piece of code. It's getting a little bit more complicated than at the beginning. Well, anything is going to get more complicated than hello world, right? But my point is, we are learning now that we can have like 2 if statements, one after the other. Now I could start asking questions such as, how many different possible ways is there, or are there, I don't know, are there to actually execute this code? Well, I could start here, 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 and I don't have a choice. Sequential execution, building block 0, right? But then I have a choice here. So I could go 1, 2, 3, 4, like execution of those lines, then here, and skip that one. Or I could go 1, 2, 3, 4, and execute that one, the else, and skip the first part of the if, right? So I have 2 choices here. And then independently of the choice that my code makes here based on that condition, I can go here and execute that line. That's one more choice, or that line. So 2 choices here for each of the possible paths of execution through the code, right? The line that actually get executed through my code, one after the other. For every possible one of the 2 paths of execution in the code up to here, I have double that amount at the end. So total, I have 2 times 2, I have 4 possible paths of execution. That's why when I was running my code, I wanted to make sure my code was working. So I could have taken 12, 12, 12, and 12. Stupid. Why would I test 4 times the same number? As long as the code is deterministic, as long as it always works the same way, there's no random number. If I get the same input, I get the same output. So it's stupid to test 4 times 12. So should I test 12, 13, 14? I don't know. What makes sense? I look at this code and I say, I want to run it several times, but when I'm done running it several times, I want to have like a 90% certitude that it's working. One of the ways to do that, and this is what I mentioned at the beginning as testing your code, one of the way I test this code is by making sure that all of the runs that I do with it, each of these is an independent test for me, right? Each of these, I'm making sure that it works when I go through those line and that line and that line. Then when it works when I go through those line and still that line, but then the else here. So that's 2 paths, then 3, then 4. I get through all the possible execution paths of my code. So what happens if I have a bunch of if statements in a method? That method is going to be a pain in the rear to test. That's why, again, for the next 2 weeks, I'm going to stretch you a little bit, make you put an if inside of if, like 3 levels. But once you get over that, once your brain has been used to that, right? Then when you write code, you want to avoid 50 million if statements in the same method, so that you keep each method easy to reason about, easy to figure out, easy to test. Okay? So we have independent tests, and the last thing is, what if we nest if statement? Well, then we talk about linked test, meaning that if value 1 greater than 0, this is the first part of that if. This is the else part of the if. What I can guarantee to you is when you're executing this code, it's guaranteed that value 1 greater than 0 is true. So when I look at this code, no matter what I test here, value 1 is greater than 0. When I look at this code, it's guaranteed that I was in the else because value 1 was not greater than 0. So there is a link, okay? When you say, is value 1 greater than 0, and then you ask the question, is value 2 greater than 0? These are linked questions. Because by the time you ask yourself if value 2 is greater than 0 here, you know already that value 1 is greater than 0. So if that is true, you go here. If that is true also, you can say both value 1 and value 2 are positive. Okay? Again, type this, play with it, tinker with it, I need to relinquish the classroom, otherwise we are going to get kicked out. So there we go. And come to office hours if you have questions, okay? Don't forget. Thank you. Hold on, just give me 1 second, because last time I forgot to stop the recording.